We've talked about this a little bit, and I had a circuit on the board that had let's say 24 volts, and I showed it that we had 8 k ohms and 8 k ohms and 8 k ohms all the way back around. And we said that the overall total resistance was 24 k ohms. In a series circuit, to figure out what the total resistance is, that means what would it be if I did this as a resistively equal circuit? Well, this is R1, this is R2, R3. Resistance total is going to equal to R1 plus R2 plus R3. In this case, it's equal to 8 k ohms plus 8 k ohms plus 8 k ohms, which is equal to 24 k ohms. Notice I'm using the designation T, okay, the actual total resistance. And again, this might be my voltage source still 24 volts. I'll mark that VS, voltage source. This has the same amount of resistance as this circuit does. Does it do exactly the same? By no means does it. It has the same amount of resistance. If I was in a black box and you couldn't see that and you couldn't see that, could you tell the difference inside the black box if it was 3 resistors or 1 resistor? No. But electronically, this may be hooked up to a certain part of it, or this might be hooked up to some other part, and therefore it would do something different electronically inside the circuit or inside the box. And this would not be able to do those because it's just not hooked up that way. So while it's electrically valued the same, the overall function may not. So be careful when doing that, because we think that we can break it all the way down and make a single resistor out of it. But the reality is not a single resistor, it is a combination of circuits. So if I had a number of resistors in here in a series circuit, it wouldn't matter what they were, how many was in there. If I had 3, I'll just kind of leave 3 up there. If I had 20 k ohms, 30 k ohms, and 50 k ohms, R1 is 20k, 30k, R2, and R3 is 50k, and for a total resistance of 100 k ohms. We're going to have that as a total resistance. The total resistance over here will be 100 k ohms. With all that resistance, it's going to restrict the flow of the current. That overall resistance is going to restrict that flow, and that we're going to see a very, very minor amount of current flowing through this. But that's, again, a theoretical circuit based on the real circuit. But that current is going to be the same throughout. So we're going to have the same current here, is the same current here, is the same current here. Each one of them will have the same current. In the next video, you'll see that how we develop a voltage across each one of those resistors. But we're going to take a step back with it.